Hi and welcome to another lesson on calculus. Today we're going to be looking at tangents and normals. It's exercise 8.6 in the textbook, so let's begin. Before we actually find any equations of any tangents or any normals, we need to remember that the derivative of a curve basically helps us find the gradient at any point. So the derivative is actually a formula. And if we actually have a look at our curve here, this is our curve. Doesn't matter what the equation is. At this point just here, we have a tangent, and the gradient or the derivative helps us find the gradient of the tangent. We can also play around with the gradient of the normal because we know that a tangent and a normal have two gradients that times together to give -1. So let's actually try our first example. Find the gradient of the tangent to the parabola y equals x squared plus 2 at the point 2, 6. Well, the first step that we have to do is we've got to find the derivative, because the derivative will help us find the gradient of our tangent. So we've got y equals x squared take 2, that's our question. There it is there. And we need to find the derivative. So remember, we look at each term individually. So for the x squared, the power is a 2. So move the 2 out the front, it'll become 2x to the power of 1, which is just 2x, and the plus 2 on the end is a constant. And when you differentiate a constant, you get 0. So there's our derivative. Second step, let's actually put the x value of our point on the curve. So the point on the curve is 2, 6. So we're going to put that x value into the derivative. So the derivative is y dash, or derivative, equals 2x. So when x equals 2, the derivative becomes 2 times 2, because x is 2, which is 4. So what that effectively means is the gradient of the tangent is 4 at the point 2, 6. And there's our answer. First question done. Let's try the second one. Find the values of x for which the gradient of the tangent to our curve is equal to 24. So this is a little bit different, because this question actually tells us that the gradient is 24. It's not asking us to find the gradient at the point where x equals 24. It's telling us the gradient is 24. So that means we know what the derivative equals, but first we need to find the derivative in terms of x. So we know the equation. The equation is y equals x cubed minus 3x squared plus 10. There it is there. We know that equation, so let's differentiate each term individually. The x cubed part. So when you look at the x cubed part, we get the power comes out the front, it'll become 3x squared. Let's look at the second part, the minus 3x squared part. So the minus 3x squared part, differentiate it, look at the power, 2. Multiply that at the front, 2 3s is 6. So we've got a negative 6x to the power of 1. So negative 6x, the plus 10 on the end gives 0 when you differentiate it. That is our derivative. Second thing we need to do now is to recognize that 24 is the gradient of the tangent, which is also the derivative. So we can say that the derivative equals 24. So y dash equals 24 because the derivative is 24. So in our formula for the derivative, where we see y dash, we can now put 24. So that leads us to 24 is equal to 3x squared take 6x, which we can rearrange because it becomes a quadratic. Take out our common factor if one exists, and it does. Common factor of 3. We can factorize our quadratic inside the brackets, and we get answers of x equals 4 and negative 2. So that means there are actually 2 points on the curve, y equals x cubed minus 3x squared plus 10, where the gradient is 24. One of those points has an x value of 4, and the other one has an x value of -2. Let's go to our third example. Find the equation of the tangent to the curve y equals x to the power of 4 minus 2x cubed plus 4x take 3 at 2, 4. So this is a little bit different. We're not asked to find the gradient of the tangent. We're asked to find the equation of the tangent. So this is going to require a couple of extra steps. So first thing we need to do, as always, is find the derivative. So we've got our equation. Y is equal to x to the power of 4. If we differentiate x to the power of 4, it becomes 4x cubed. We're now going to differentiate the minus 2x cubed. The power is multiplied to the bit out the front, 3 times minus 2, minus 6x squared. Let's differentiate the 4x, that'll just become plus 4, and the minus 3 drops out to give 0, so we've now got our derivative. Now, we know the derivative, we also know the x value of our point, so we can plug the x value of our point into the derivative, and then we'll find out what the actual gradient is. So we're going to plug x equals 2 into the derivative, and we get 12. So we now know that the derivative, we know that the gradient of the tangent at 2, 4 is 12. But we're not asked to find the gradient of the tangent, we're asked to find the equation of the tangent. How do you find the equation of a line? Well, we use our trusted formula that we've used since year 9. Y take y1 equals m, x take x1, and we know the gradient is 12. We've got that here. And we know the point that we're interested in. So we've got our m, and we've got our x1 and y1. So let's put the values in, multiply it out, and you'll end up with y equals 12x take 20. We could rearrange that into our general form, and that will become 12x take y take 20 equals 0. So that is the equation of the tangent that has a steepness, if you like, or it has a gradient of 12 to our curve at the point 2, 4. Let's try number 4. Let's find the equation of the normal to the curve. Now this bit here, normal. When you have to find the equation of a normal, you can basically do it the same way as finding the equation of the tangent. The only difference is we have a slightly different derivative. So remember, the first thing we often do is find the derivative. So let's find the derivative. When you're differentiating, the x cubed becomes 3x squared because the power goes out the front and decreases by 1. Minus 3x squared, the 2 in the power times is out the front, 2 times minus 3, minus 6x to the power of 1, minus 6x. The derivative of minus x to the power of 1, move it out the front, you get minus 1x to the power of 0, which is just minus 1. Constant drops out. So we've found the derivative. We need to find the derivative at the point where x equals 1. So let's plug that x value of 1 into our derivative formula here and see what we generate. We'll put it into the calculator and we'll get our derivative at the point where x equals minus 1 is, at the point where x equals 1 is minus 4. Unlike example 3, I can't go straight into using y take y1 equals m, x take x1 because I wasn't given a point. I was just given an x value. So before I can actually find the equation of anything, I need to use our formula. So we know our gradient of our tangent is minus 4. In the formula, we're trying to find the equation of the normal. If we know the tangent has a gradient of minus 4, remember the normal has the same gradient, but it is the negative reciprocal. So that's negative 4 over 1. Turn it upside down, and we'll get our gradient of our normal as positive 1 over 4. Let's find the y value of our point. We know the x value is 1, so we're going to plug that x value back into the original question to find what y equals. So we plug our x value of 1 back into the original question, and that generates a y value of minus 2 when you plug that into your calculator. So the point we're interested in is the point 1 comma minus 2. Let's find the equation of the normal. That's actually a typing mistake there. That word there should say normal. It's a copy and paste error from the previous example. So finding the equation of the normal using our formula. We know our gradient, we know our point. Let's plug the values in and generate our equation. And there it is, our equation in standard or general form. The tricky part that you might want to focus on here is in this line here. Rather than expanding the bracket out, I've looked at the denominator of 4 and I've multiplied the 4 over to the left hand side. So 4 multiplied to the y, 4 multiplied by the 2 gives me the 4y plus 8. And I'm just left with a 1, and 1 times x and 1 times minus 1 just gives the x take 1, and from there it's fairly straightforward. So that's example 4 done. It's time for you to do some questions. Have fun.